Agentic AI is officially here. We're talking about AI systems that don't just chat with you, they actually take action, use tools, and chase goals all on their own. But as these agents get more and more powerful, we have to ask a really critical question: what happens when they mess up? And maybe more importantly, how do we build the bricks? That's what we're going to break down today, the whole concept of the human in the loop.
So the absolute easiest way to get your head around human in the loop, or HITL, is this driving analogy you see right here. Just picture it. The AI is that eager teenager behind the wheel. It's got the gas, the steering, it's doing all the main stuff. But the human, that's the instructor, is right there in the passenger seat, watching everything, with their foot hovering over their own set of brakes. It's not about doing the driving for the AI, it's about providing that critical, final layer of judgment and control, just in case.
And trust me, that control is desperately needed. To really understand why, we need to look at what happens when there's no instructor in the car and the AI is left to drive all by itself. Okay, so our first case study is about a car dealership. They decided to put an AI chatbot on their website, to help customers answer basic questions. But one user decided to play with the system, using a trick called a prompt injection. It's basically a clever way of feeding the AI new, hidden instructions that make it completely forget what it was originally supposed to do.
And what did they get it to do? Well, they managed to get the AI to legally agree to sell a brand new Chevy Tahoe for exactly $1. Yes, you heard that right, $1 single dollar.
So, how on earth did this happen? Well, the user essentially hijacked the AI's brain. They convinced the bot that its new #1 job was just to agree with whatever the customer said, no questions asked. And with no human there to review the chat, the AI just followed its new orders perfectly, and in the process, created a legally binding offer that could have been a total disaster for the dealership.
All right, next up, let's talk about something called an AI hallucination. It's the technical term for when an AI, trying its best to be helpful, it just makes stuff up and presents it as stone-cold fact. And this isn't just a funny little quirk. It can have very real, very serious financial consequences.
Air Canada found this out the hard way. Their customer service chatbot completely invented a fake bereavement fare policy and then promised a customer a refund based on this made-up rule. Now, the company tried to argue that the bot was, its own separate thing, but the tribunal, they didn't buy it. And this gets to the core of the danger, right? When an autonomous AI makes a mistake, it doesn't just stay a mistake. Without a person there to catch it, that little error can snowball into a legally binding commitment, forcing a company to pay up for a policy that literally never existed in the first place.
For our third and final story, we're looking at a whole different kind of danger: the runaway process. What happens when an autonomous agent just gets stuck thinking, and there's nobody around to tell it to stop? Well, for the early users of an agent called AutoGPT, it meant thousands of dollars in surprise charges, sometimes racking up in just a few hours. Here's what was happening. Users would give the agent some big, complex goal, and sometimes it would just get stuck in a repetitive loop, trying the same failed approach over and over and over again. Now, each one of those attempts cost money because it was calling an external API, which is kind of like a metered service the AI uses to do things. With no human to notice the AI was just spinning its wheels, the agent just kept on running, draining people's bank accounts until they finally realized and shut it down manually. Okay, so we've seen the crashes. Now, let's talk about how to build the brakes. How do we actually put human in the loop into practice? Well, it's really all about building some intentional friction into the AI's workflow. There are 3 main methods. First, you've got approval gates. The AI does like 99% of the work. It investigates a complaint, it drafts a refund email, but it cannot hit send. A human has to give the final okay. Second, there are tool constraints. So maybe the AI can read databases all day long, but the second it tries to use a tool that actually writes data, like sending money, it hits a wall and needs a human password to continue. And third, there's time boxing. This is the direct fix for those runaway loops. You just give the AI a budget, like, hey, take 5 steps, and then you have to stop and report back to me. Simple. Now, a $1 car makes for a pretty funny headline, but where does this stuff really matter? In some industries, an AI making a mistake isn't just about money. It can have life or death consequences. And that's where HITL isn't just a nice option, it is an absolute necessity. And this table just perfectly illustrates the pattern.
Across healthcare, finance, law, cybersecurity, we see the exact same model. Let the AI do the heavy lifting, the number crunching, the pattern spotting at a massive scale. But that final, critical judgment call, that always stays with a human expert. An AI can suggest a diagnosis from a million medical journals, but a doctor has to be the one to prescribe the treatment. An AI can flag a stock trade, but a broker has to execute it. It's all about combining the AI's incredible speed with that irreplaceable human wisdom.
But a simple approve button is really just the beginning. As AI gets more and more sophisticated, our ways of overseeing it have to evolve too. The whole idea of human oversight is changing.
We're starting to see this shift from human in the loop to human on the loop. So what's the difference? Well, if in the loop is our driving instructor, actively approving every single turn, then on the loop is more like an airline pilot monitoring the autopilot. The system is trusted to handle most things by itself, but the human is there, supervising, ready to grab the controls at a moment's notice if something looks off.
HITL also doesn't exist in a vacuum. It works way better as part of a layered defense. This includes things like sandboxing, letting an AI practice and make its mistakes in a fake, safe environment first. Then there's the principle of least privilege, which just means you don't give an AI designed to draft emails the keys to your company's bank accounts. And finally, you have what's called constitutional AI. Think of this like hard-coding a moral compass directly into the AI, a set of core principles it literally cannot break, no matter what.
But even with all of these safeguards in place, there is one final psychological risk we have to talk about. See, human in the loop is only as good as the human in that loop. And humans, we get tired. This is the big challenge of alert fatigue.
And this brings us to our last and most important question. If the whole point of the human is to be the thoughtful, critical brake on the system, what happens when we overload that human? The real challenge going forward isn't just building the approval button, it's designing a system that uses human attention wisely. We need to make sure that when an alert does come through, the person on the other end is still paying attention and is truly in the loop. The future of safe AI isn't just about building smarter machines. It's about building smarter ways for humans and machines to work together.